functions. You see, a function is a rule that assigns to each element in the set of input values, which is also known as the domain, to one and only element in the set of output values, which is also known as the codomain. You see, let A and B be non-empty sets. You see, a function from A into B, which is denoted as function of A into B, is actually a rule that assigns to each element of A exactly one element of B. And you see, A and B are called domain and codomain, respectively. Well, as we look at this, so many terms have been used, and we want to define all of those terms. First of all, what is a set? A set is a collection of objects known as elements or members that can be anything, numbers, letters, symbols, etc. So please, okay, sets actually are often, there's a full stop here, please take notes. Sets are actually often denoted using curly brackets. This is a curly bracket. And elements of sets are separated by commas. You can see this set A. When you see this, means set A is equal to, you see, these are the elements in set A, 2, 4, 6, 8, and 10. Each of them are separated by commas. And this is the curly brackets. Okay, so this is set B as well, and the elements in B. The next thing I want to talk about is empty and non-empty sets. A set which contains no elements is called an empty set. Nothing is inside, and is denoted as this, or a curly bracket that has nothing inside of it. So look at this now. E is equal to all prime numbers divisible by 4. Since no prime number is divisible by 4, then E is an empty set. You write like this or you write like this. Please, some think that it's written like this, but it's wrong. No, you are trying to say set E contains nothing. So it contains something actually. That's what you're trying to say. But it's wrong to write like this. Very, very wrong. Take note. Okay. So a set which contains at least one element is known as a non-empty set. So you often hear us use the word non-empty set and all that. But take note that this is what it means to say non-empty set or empty set. So a non-empty set contains at least one element. Could be more than one. Look at this G, for instance, set G. Set G contains 4 elements. And set H contains 3 elements. So set G and H are non-empty sets. So next, let's look at domain, codomain, range of a function. You see, the domain of a function is the set of all possible independent or input value, or we call it the X, for which a function is defined. I will illustrate that as we continue. And then we have the codomain. The codomain of a function is the set of all possible dependent or output value. Please, this output value, that is the Y value of a function. Now it's important to note that not all elements of the codomain are images of the domain. Not everything you see in the codomain is actually the image of the domain. We'll look at that. We'll see that though. The next is range. A range of a function is a collection of all outputs of or images of the domain. Now let's illustrate all of this now. Let's say for instance this is X, which is the domain, the independent variable, -2, -1, 0, 1, 2, and 3. And Y is -3, -2, -1, 0, 1, 2, 3, 5, and 7. The Y now is the dependent or the output, and this is the input. Be non-empty set of R. R means real numbers actually. Now let's function of X onto Y be a function divided by the rule 2x plus 1. It means that we take everything in this X, multiply it by 2 and add 1 to it. If you take this first one, multiply by 2 and add 1 to it, you get -3. Take this one, multiply by 2 and add 1, you get -1. If you take this one and add 1, take this one and multiply by 2 and add 1, you get 1. If you work on this, you will have 3. Work on this, you have 5. Work on this, you have 7. Okay, so take note. Now this can be illustrated as shown. So everything in our x, this is it. And everything in our y, this is it. Now, we understand that this is related to this. So now, minus 2, minus 3. Let me do that properly. Minus 3 is the image of minus 2. And then for minus 1 now, minus 1 is the image of minus 1. And 0 is the image, 1 is the image of 0. 3 is the image of 1. 5 is the image of 2. And 7 is the image of 3. So understand now that this minus 3, minus 1, 1, 3, 5, and 7 are images of everything we have here, and they are what we call the range. So not everything we have here actually range. Like minus 2 now is not part of the range. 2 is also not part of the range. So that's what the range, domain, and codomain means. So this is the domain, this is the codomain. And minus 3, minus 1, 1, 3, 5, and 7 are actually the range. Example 1. Let f of x be x squared minus 3x plus 2. Find the following. A, f of 2, b, f of 0, c, f of minus 1. Let's take the first one now. Well, first of all, we are told that f of x is equal to x squared minus 3x plus 2. So the first one, A, we are looking at f of 2. F of 2 means put x as 2. That will be 2 squared minus 3 into 2 plus 2. This will give us 4 minus 6 plus 2. And that will give us 0. B, f of 0. F of 0 means put x as 0. That will be 0 squared minus 3 times 0 plus 2. And this will give us 0 minus 0 plus 2. And that's simply 2. And lastly, f of minus 1. And that will be minus 1 squared minus 3 into minus 1 plus 2. So this will give us 1 plus 3 plus 2. And that's simply 6. Composite functions. The process of combining functions so that the output of one function becomes the input of another is known as composite of function. It's also known as function of functions, meaning that there are functions inside another function. Well, let's look at this now. You see, let f of s and g of x be well-defined functions. Then the composition of both functions can be written as f of g of x or g of f of x. Well, I will explain this further when we take an example. Look at this now, example 1. Given that f of s is 3x plus 1 and g of s is 2x minus 1, find A, f of g of x, b, g of f of x, c, f of x. Now, this is what we call function of function because this singular thing here contains two functions inside of it. Now, let's take the first one now. A, f of g of x. This is simply going to be f of, what is g of x? We write that out. It is 2x minus 1. So this is f of 2x minus 1. So I've done this first of all, write out my g first of x first. Now f of this simply means that in place of x in this formula, you know, when you say f of x, it simply means take what is here and multiply it by what? 3. That is 3 times x, then plus 1. If I said f of 1, it simply means take what is here, 3, multiply it by 1, and then add 1 to it. If I say f of 2x, for instance, it means take what is here, multiply it by 3. That is 3 times 2 of x, then plus 1. If I say f of this, what would it be? It simply means 3 times what is here, because that's what f of x means. 3 times what is here, that is 2x minus 1. And then after you multiply it by 3, you add 1 to it. That's what it simply means. So eventually this is going to be 3 times 2, that's 6x. 3 times that's minus 3, then plus 1. And this will be 6x minus 2. That's f of g of x. Now let's take the next one. G of f of x. This is simply going to be g. Then let's take our f of x first. f of x is 3x plus 1. As you look at this now, what is g of this? G of x means multiply whatever is here by 2 and minus 1 from it. So this is going to be 2 multiplying 3x plus 1 and minus 1 from it. So this is going to be 2 times 3x, that's 6x. 2 times 1, that's plus 2. And then minus 1 from this. So this is going to be 6x plus 1. Lastly, f of x. So first of all, I'll do f of, what's f of x? 3x plus 1. And then now, f of this will be, multiply what is here by 3. That is f, that is 3 times 3x plus 1. Then add 1 to it. So this will be 9x plus 3 plus 1. And that's 9x plus 4. That's that for this. Example 3. Or we can say example 2 under composite function. Given that f of x is 3x squared minus x plus 10, and that g of x is equal to 1 minus 20x, find f of g of x. So, f of g of x will be equal to f of, what's our g of x? That's 1 minus 20x. So f of x is simply multiply that x, square that x and multiply it by 3, then minus that same x plus 10. So that will be square 3 times square of this first of all. Then minus this same thing. Then plus 10. So this will be 3 into, if we square this, we're going to have 1 minus 40x plus 400x squared. Then minus 1 plus 20x plus 10. So opening up this will give us 3 minus 120x plus 1200x squared minus 1 plus 20x plus 10. So this is 1200x squared. 20x minus 120x will give us minus 100x. And then 3 minus 1 will give us 2. 2 plus 10 will give us 12. That's the final answer for this. This is the first one. Let's take the second one now. B, g of f of x is simply g of 3x squared minus x plus 10. So this will be, for g of x is 1 minus 20 times that x. So this will be 1 minus 20 times, everything here will look like the x now. That is 3x squared minus x plus 10. So this will be 1 minus 60x squared plus 20x, then minus 200. So this will be equal to minus 60, x squared, and then plus 20x, and then lastly minus 199 as the final answer for this. Let's take the last one now. C, g of x. This is g of 1 minus 20x, and this is equal to 1 minus 20 times 1 minus 20x. So this is 1 minus 20 plus 400x. So this is simply 400x minus 19. Inverse function. You see, the inverse of a function f of x is denoted by f prime of x. A function is said to be inverse of a function if f inverse of f of x would give us x. I would explain actually. If you operate f prime of x, f inverse of f of x, you should get back the x, the input value of variable. That's what it actually means to be inverse of a function. Now let's take example here now. Given that f of x is equal to 2x plus 1, find the inverse of f of x. Let's solve this now. Let's say that f of x, let the inverse of f of x be g of x, for instance, we can say y, which is what we call f of x, be equal to 2x plus 1. And so let me write that y is equal to 2x plus 1. We can make y a formula now. That's to say, bring this one here. That will be y minus 1 is equal to 2x. Dividing both sides by 2 now, we can say that x is equal to y minus 1 over 2. Now, we can say f prime of x is equal to x minus 1 over 2, which is what we call the g of x. So this is the inverse. When you make x a formula, you now say that thing is called, this relationship now is called the inverse. Just changing the y to x. That's what last thing we'll do. Just change the y here to x. So that's that about this question. So this is the inverse, x minus 1 over 2. So example 2, f of x into x is, or f of x is equal to, example 2, f of x is equal to x plus 1 over x minus 2. Be a function defined by on the set of real numbers, except 2. Find f inverse of 3. So the first thing we'll do is say y, which is our f of x, is equal to x plus 1 over x minus 2. So we can say y is equal to x plus 1 over x minus 2. Now we can cross multiply now. If you cross multiply, you get y into x minus 2 is equal to x plus 1. Okay, so let's open up that now. That will be xy minus 2y is equal to x plus 1. Okay, so let's rearrange now. Bring this here and bring this here. We'll get xy minus x is equal to, this comes here now, 1 plus 2y. Now x is common here. That will be y minus 1 is equal to 1 plus 2y. Actually, the goal is to make x a formula. So now dividing here by y minus 1, divide here by y minus 1. We'll get that x is equal to 1 plus 2y over y minus 1. So we've done that now, making x a formula. So we can say f inverse now of x is equal to 1 plus, just substitute in place of y, x now. So 1 plus 2x over x minus 1. So this is the inverse function. They say we should find f inverse of 3. That in place of this now put 3, in place of x put 3, that 1 plus 2 into 3 over 3 minus 1. And that will give us 1 plus 6 over 2. And that will be 7 over 2.